Now, let's then the next step really is to have some. I mean, it's kind of boring right now, just an oscillator, and it's a fixed oscillator at that. So let's find a way to change our pitch, right? And we did this before. It's really here, this argument right here. So if I wanted to hard code something, I can do that. But every time I made a synth, it would just play this 200 hertz sine tone. And we learned earlier that we can make that a variable, so an argument, I guess, which is a variable that's set from the outside. And remember, arguments need to be on the first line, so I'll make an arg, and I'll call it freq. Okay, and then I can just pass that argument into the frequency range here. And it's always a good idea to give a default, so let's make it 300. So now this frequency will be passed in, and I can use a set argument. Or I can start my synth, or create my synth with the arguments intact by using this notation as well. Okay. So either way, so if I do that, if I evaluate that, and then I create a sine wave with a 500 frequency, I can set it to 200. And that's already much better, so we can at least change our pitch. Now, I'm also going to introduce a conversion way, because sometimes it's not the most helpful thing to think about pitch in terms of hertz or cycles per second. So if I said, oh, I want an A sharp, unless you had, your charts memorized, I wouldn't really know how many hertz to put down. I'd have to look it up. So you don't want to be doing that every time you want to play a pitch and then set that in. So one way is to use MIDI notes. So I'm going to change this, even though I showed you this way, just to show how frequency was passed into our sine wave oscillator. I'm going to actually change this argument, and I'm going to make it pitch. All right. And when I say pitch, I'm going to use MIDI note numbers. Now, if you're not familiar with that, you can read up on that. I won't explain it too much here. But the MIDI note numbers are basically numbers assigned to notes on your MIDI keyboards. And it's a nice linear scale. So, for example, C, middle C, C4, is the number 60. And then C sharp would be 61. And then D would be 62, etc. All right. So it's a nice linear. Whereas with hertz, it changes every time. I'm not sure what numbers those are. All right. So I'm going to have a pitch, and I'll just set that to middle C, 60, which is my MIDI note number. But were I to just pass that pitch into here, it will give me a 60 hertz sine wave, which is very low, and it's not very close in pitch to middle C. So I'm going to do a little conversion here, which SuperCollider, since it's a program for generating audio, has a number of shortcuts and little helpers that helps you make some common conversions and such. I'm going to create a new variable, and I'm going to call that variable freq. Okay, and I'm going to say the freq, or the frequency, is going to be equal to the pitch converted. And to do that conversion is very simple. I'm just going to use a little function called dot CPS MIDI. Okay, so oh, sorry, wrong way. MIDI CPS. Okay, so MIDI meaning the MIDI note, and CPS meaning cycles per second. It's going to convert my pitch 60 to a cycles per second frequency, which is what this UGen sine os expects. It expects a frequency in hertz. Okay, again, if I just passed it directly to the pitch, it would be a very low 60 hertz tone. So this .MIDI CPS converts it, and now frequency is being converted to 2 hertz, and I can just pass that there, and everything should be fine. So if I go ahead and evaluate that, and then I'm going to, now you notice my argument is no longer frequency, it's pitch. So I gotta make pitch argument, and then 500 would be very, very high. So I'll just make this, say, whatever, a few notes down, say 55, like that. And then I'll have to change my set as well, pitch. And we'll just go up the scale, 7, something like that. Okay. So if I create that, create a 55, 57, and then you can imagine going up the scale. 58. You can go chromatically if you want. 59. And then back to middle C. Right. Okay, so let's wrap that up there. This gives you an idea of how to change arguments, and you can also do conversions within your synth. For our purposes, for our mouse theremin, it's very handy to think about pitch in terms of MIDI notes. Okay.